Hi, in the last video, I have given a complete overview of VLSI. Now, in this video, I'm going to explain how we design any kind of chip, what are the various steps we follow as part of the design process, what is front end, what is back end. Let's look at the details. This is how the design flow would look like. It starts with the specification and ends with GDS2. Now, there are two major domains. If you look at this design process, specification to synthesis, it falls under front end, and the remaining steps which are related to P&R, they fall under back end. Now let's look at every step in detail. I will walk you through all the steps. Specification. I want you to understand how we create this specification. Experienced engineers like me, engineers who have more than 20 to 30 years experience, we call them as architects, they define the specification. What they do is they interact with the marketing team, they collect all the details. So marketing folks, they always interact with the consumer. They try to find out what's their experience with respect to previous version, what kind of difficulties they faced, how they enjoyed the product, what are the good things, what are the things that need to be improved, and what are the various features that we need to include to compete with the competitors. So this is how the architects collect all the details from the marketing team, and then they look at the feasibility, like how many features, new features we can include, and how the new product is going to be, they visualize. Now let's look at how these architects define the specification. You take any electronic system, it's composed of both hardware and software. For example, iPhone. iPhone has both hardware and software. If you look at the hardware, there is a PCB inside, and the PCB has got a chip on it. It's called SoC. We discussed about A11. This is the main component of the iPhone. In addition to this, basically it needs some software. So here iOS acts like user interface. This is how we realize any kind of electronic system. So these architects take the system specification and they partition the specification into hardware and software, and they define hardware specification and software specification. We chip designers take the hardware specification and design the chip. In case of iPhone, it's going to be A11, and whatever the chip we design, finally it goes as part of the board. The chip will be on the board, and in parallel, the software programmers create the software, and finally they run software on the hardware, and then they try to verify the entire system. So it's called hardware software co-verification. Now, if you look at the hardware specification, we need to look at how much the chip is going to be complex. If it's going to be very complex, then we might want to go with ASIC, or if it's not very complex, then FPGA might do, or even in some cases, even standard chips might also do. This is how basically we approach. Now let's look at the ASIC. To design the chip, what are the important things that we need to look at? Specification is nothing but a document. It can be a PDF or it can be a Word document. Usually it's huge. There will be thousands of pages. Then you need to really understand how to approach this specification. So when it comes to specification, you have to look at certain important details like the interface, packet structure, and protocol. Let's look at the details. What is the interface? Interface is nothing but inputs and outputs. So to design any chip, you need to understand how many inputs, how many outputs, what kind of clock, what kind of reset, synchronous or asynchronous. And the packet structure. What is the size of the packet? What is payload? What is address? What is parity? What kind of parity? And how we can drive the packet to the chip, because the chip is a digital component, it can understand only the binary. You can't drive any packet or frame. Then you have to convert the packet into binary. So are you going to drive something like bit per clock cycle or byte per clock cycle or more than 1 byte per clock cycle? That's what the protocol defines. So these are all the important things. In VLSI, protocol is very important. We always follow standard protocols like AHB, AXI, APB, SPI, UART. Now, when it comes to building complex SOCs, basically we connect various IPs. When it comes to connecting IPs, we follow the standard protocols. So you need to be good at certain protocols to get into VLSI industry. Now let's come back to the specification. Specification may have so much of information. There may be too many chapters, but you have to really look at the important details to start off with the design. And once you get into the implementation, then if there are any questions, any doubts, then you may want to refer a particular chapter to understand more. Now, you understood the functionality. It's time for you to create the architecture. Usually, experienced architects create the architecture. If you recollect, this is what we discussed during mobile SoC architecture. Basically, architecture is nothing but a block diagram. You can find all the details, like how many IPs would be there and how all the IPs would be connected, something like on-chip bus. And the experienced architect will give the ownership of any particular IP or any particular subsystem to a technical lead. Then the technical lead will create the architecture something like this. For example, how the processor can be created. You might create architecture something like this. This might not be the exact architecture of ARM core, but this is how any microcontroller can be realized. It needs various kinds of components like arithmetic logic unit or decoders or registers. And then you may ask engineers like you to design a particular component. For example, you are new to the organization, then you might ask you like, hey, why don't you design the arithmetic logic unit? Then you might want to apply your digital knowledge and create the microarchitecture, something like this. Then there will be different engineers, they create different components, and finally the tech lead is going to put all the components together, and then he's going to create that particular subsystem. Thanks for watching this video. Thank you.